we always get into some pretty interesting stuff here on the deep dive.
Yeah.
But the sources you sent over this time on free logic.
Okay.
Okay, this one really got me excited. We're talking about something that really challenges how we usually think about logic
That's right.
and existence.
Yeah.
It's like a whole new level.
For philosophers especially.
Right.
For philosophers who are like wrestling with questions of ontology, the relationship between language and reality.
Oh, yeah.
Free logic provides a crucial alternative to classical logic.
Like a whole different framework.
Yeah, exactly.
Okay, so break it down for me.
Okay, so the core shakeup, the core difference is that classical logic operates on this unspoken assumption that every singular term we use,
Okay.
like every name, the this or that,
Right.
actually refers to something real,
Got it.
something within our defined scope of discussion.
Which, for philosophers, I can see how that could be a problem.
It's a big problem.
Because you all are constantly dealing with stuff that...
We love talking about things
Yeah.
that might not exist.
They're like, their existence is the whole point of the debate.
Exactly.
Like abstract concepts,
Yeah.
fictional things,
Yes.
possibilities even.
Possibilities, all of that.
It's a whole world out there
Exactly.
that classical logic can't handle.
Struggles.
Yeah.
It really struggles.
I mean, think about the classic philosophical question.
Oh, yeah.
What is non-being?
Right.
Like, classical logic just...
It ties itself in knots.
Yeah.
It's like, how can you even talk about it
Right.
without already assuming that it is something?
The whole thing falls apart.
It does.
Yeah.
Free logic steps in here.
Okay.
And it offers us a way out.
Okay. I'm intrigued.
It allows us to use terms
Yeah.
that don't necessarily have to hook onto something concrete.
So it's more flexible.
It is.
It doesn't force us to say, like, this thing exists.
It doesn't make that demand
Yeah.
just to be able to talk about it.
Yeah. Okay, that makes sense.
And that's where the free logic comes from.
Huh.
It's free from that really strict existence assumption.
That kind of baggage
The
classical
right.
logic is carrying around.
That's built into classical logic.
Yeah, it's just assumed.
And this area really became a formal field of study
Okay.
with the work of Carol Lambert,
Okay.
who in 1960 coined the term.
Free logic. Yeah.
Yes.
Okay.
To describe a logic free of existence assumptions with respect to its terms.
I mean, that's a pretty big deal for philosophers.
It is.
Like, to be able to talk about things without this constant...
Without that existential burden.
Yeah, without that burden.
Yeah.
So where does this freedom really make a difference?
Okay, so one immediate area
Yeah.
is in how we analyze statements about things that were once believed to exist, but then turned out not to.
Like what? Give me an example.
Like the luminiferous ether.
The ether.
Yes.
Like from the 19th century.
Exactly. This was this supposed medium.
Yeah, I vaguely remember this.
It was thought to be this stuff that light waves traveled through.
Right, like it had to be traveling through something, right?
Yeah, that was the thinking at the time.
Okay, so what's the free logic take on this?
Well, scientists back then would say things like,
Yeah.
we detect no motion of the Earth relative to the ether.
Right.
Now, from a classical logic standpoint,
Yeah.
because the ether doesn't exist,
Right.
that statement starts to look nonsensical.
Because it's referring to something that isn't there.
Exactly.
Yeah, classical logic doesn't like that.
It gets very uncomfortable.
It's like saying,
That's like that classic example.
Yeah.
The current king of France is wearing a hat
Right.
when there is no current king of France.
It just doesn't make sense.
Doesn't.
Classical logic just throws its hands up in the air.
Exactly.
So how does free logic approach the ether problem?
It provides a more nuanced approach
Okay.
for a philosopher trying to understand the history of science and what these statements meant at the time. Free logic lets that statement, we detect no motion of the Earth relative to the ether, be true.
Okay.
Precisely because the ether doesn't exist.
So it's like the absence of the ether is what makes the statement true.
Yes, exactly.
That's pretty wild.
It is a shift in perspective.
Yeah.
And free logic can even handle the truth of the statement, the ether does not exist.
Okay, but how? Doesn't that create a contradiction?
In classical logic, it would.
Yeah.
Because just using the term the ether would imply it exists.
Right.
But free logic avoids that.
So it lets you talk about the non-existence of something without tying yourself in knots.
Exactly.
That's a really powerful tool for philosophers.
It is.
Especially when you're dealing with concepts that might not actually exist.
Absolutely.
So if we're no longer demanding that all our terms refer to something real, does that mess with the basic rules of logic?
It does.
Like the ones philosophers use all the time.
Yes, some of the fundamental inference rules that are totally valid in classical logic
Yeah.
become invalid in free logic.
Like what? Give me an example.
Take universal instantiation,
Okay.
which is the rule that says, basically,
Yeah.
if everything in a domain has a certain property,
Okay.
then any specific individual in that domain also has that property.
Right. The classic example.
Yes.
All humans are mortal.
Yes.
Socrates is human.
Yes.
Therefore, Socrates is mortal.
Precisely.
That's like logic 101.
Exactly.
But you're saying that doesn't always work in free logic.
It doesn't.
Why not?
Because if the term you're using doesn't actually refer to anything in your domain,
Okay.
then even if everything that exists in that domain has the property,
Yeah.
you can't conclude that the non-existent thing also has that property.
So it's like the term is floating out there.
It's unanchored.
Yeah, unanchored.
It's not tied to anything real.
And that breaks the inference.
Exactly.
Okay, I see.
Like in our ether example,
Right.
even if we said something like,
Yeah.
everything that exists is subject to empirical verification,
Okay.
we couldn't use universal instantiation to conclude that the ether is subject to empirical verification.
Because it doesn't exist.
Precisely.
So it's outside the domain of things that the rule applies to.
Exactly.
Okay, that makes sense.
It's a subtle but really important difference.
Yeah, it is.
And it affects how we reason about existence.
What about existential generalization?
Yeah.
That's the other big one, right?
It is.
Where you go from a statement about a specific thing
Yeah.
to a claim that something with that property exists.
Precisely.
Does that one hold up in free logic?
It also runs into trouble
Yeah.
when the term you're using doesn't actually refer to something in your domain.
So, like, if I say
If you said,
Vulcan, the hypothetical planet,
yes,
perturbs Mercury's orbit, even
Done.
if that statement was somehow true.
let's grant it for the sake of argument.
Yeah.
Even then,
Mm.
free logic wouldn't let us jump to the conclusion.
That something perturbs Mercury's orbit
Exactly.
because Vulcan isn't there.
Precisely.
It's like free logic is more cautious
Okay.
about making claims about existence.
It's more conservative in its inferences.
Right. It doesn't just assume things exist because you mention them.
Exactly.
So it's rejecting some of these classical inferences.
It is.
But is it adding any new ones?
It's not.
So it's not like it's going wild and making up its own rules.
No, it's more like it's refining the rules.
Okay.
So for a language with the same vocabulary,
Mm-hmm.
free logic is strictly weaker than classical logic, meaning fewer inferences hold.
Got
It's
it.
more restrictive in a way.
Okay, so some familiar moves are off the table.
Yes.
But how does free logic actually talk about existence then?
That's where the existence predicate comes in.
Okay.
It's often written as E.
E.
Yes, E.
All right.
And you apply it to a term like ET.
Okay.
And that statement is true if and only if the part actually denotes something in your domain.
So if it refers to a real thing,
Exactly.
and if it doesn't,
If it is an empty term, then ET is false.
so it's a way to directly say whether something exists or not.
Exactly.
It's like a built-in existence checker.
It is.
That's pretty neat.
And this existence predicate can be either
Yeah.
like a fundamental part of the system
Okay.
or in systems that include identity.
Right, the sign.
Yes.
Okay.
It can be defined in terms of identity.
How so?
Well, to exist is to be identical to something.
Which is yourself.
Exactly.
So you could define it as XT.
Precisely.
So to exist is to be identical to something,
Yeah.
which is, well, you.
Yourself.
Got it.
It's a neat way to connect the concepts of existence and identity,
Yeah, I can see how that would be interesting for philosophers.
especially those working on metaphysics.
Right.
And this existence predicate also lets us recover
Yeah.
some of those classical inferences that we lost.
Oh, really?
Yeah.
How does that work?
Well, universal instantiation becomes valid in this form. AXA, ET, ATX.
So you're basically adding the existence condition.
Exactly.
You're saying we can only conclude that T has property A
Yes,
if we also know that T exists.
precisely.
It's like a safeguard. It
Exactly.
makes sure we're not talking about non-existent things.
And existential generalization also gets modified.
How so?
It becomes AETET.
So again, you're adding the existence condition.
Yes.
You're saying that the truth of a statement about T
Mm-hmm.
only lets us infer the existence of something with that property.
Yeah.
If we know that key itself refers to something real.
It all comes back to existence.
It does.
It's like the cornerstone of this whole system.
It's a central concern in free logic.
So E gives free logic this flexibility
Yes.
to handle non-existent things,
Mm-hmm.
but also this precision
Yes.
when it comes to making existence claims.
It allows for both.
Which is pretty powerful.
It is a powerful combination. Now, you mentioned inclusive logic earlier.
Yes.
How does that fit into all of this?
Inclusive logic takes the core ideas of free logic a step further.
Okay.
So remember how classical logic assumes two things.
Refresh my memory.
It assumes that all singular terms refer to something.
Right.
And that the domain of discussion isn't empty.
So there's at least one thing we're talking about.
Yeah, exactly.
Okay, got it.
Free logic rejects the first assumption.
Right, about all terms referring.
Yes.
But it keeps the non-empty domain.
Yes.
So what does inclusive logic do?
Inclusive logic rejects both assumptions.
Whoa, hold on.
It goes all the way.
So it's saying we don't have to assume that any terms refer.
Yes.
And we don't have to assume that there's anything in our domain.
Precisely.
So it can handle a completely empty universe.
You can?
Like pure nothingness.
It allows for that possibility.
That's a pretty radical idea.
It is.
What does that do to our usual logic?
It has some interesting consequences.
Like what?
Well, take the statement X, which in classical logic
Yeah.
is a logical truth.
Because something exists and it's identical to itself.
Exactly.
It's pretty basic.
It does, but in inclusive logic,
Yeah,
if the domain is empty,
right.
there's no X to satisfy that statement.
So it becomes false.
It does.
So something that's a basic truth in classical logic
yeah.
could be false in inclusive logic?
If there's literally nothing,
That's mind-blowing.
it challenges some fundamental assumptions,
Yeah.
and any existential claim
Yeah.
becomes false in an empty domain.
Because there's nothing to exist.
Precisely.
So inclusive logic really forces you to think carefully
It does.
about existence.
Makes you justify your existence claims.
You can't just take them for granted.
Exactly.
What about universally quantified statements?
Those behave differently too.
Okay.
In an empty domain,
Yeah.
XXA is considered vacuously true,
Vacuously true.
meaning it's true because there's nothing to make it false.
Okay, I think I see.
There are no counterexamples.
Right, because there's nothing there at all.
Exactly.
So what's the problem with that?
Well, it can lead to some counterintuitive results.
Like what?
For example, the statement XPAP.
Which is a contradiction?
Yes, in classical logic, it would be always false.
Right.
But in an empty domain,
Yeah.
it becomes vacuously true.
Because there's no X to make it false.
Precisely.
So a contradiction can be true.
In inclusive logic, in an empty domain, yes.
That's really messing with my head.
It does challenge our intuitions,
Yeah.
and it also invalidates some other classical principles,
Like what?
like the principle aka,
Okay.
when X isn't free in A, meaning that A is just a statement
Sure.
that doesn't depend on any particular object.
Got it.
So if A is just a false statement
Yeah.
and the domain is empty,
Uh-huh.
that implication fails.
Because the universally quantified part is vacuously true,
Exactly.
but the statement itself is false.
Yes.
So the implication doesn't hold. It's like inclusive logic is rewriting the rules of the game.
It is forcing us to re-examine our logical foundations.
Yeah. It's definitely making me think differently.
That's a good thing.
I guess so.
It's pushing the boundaries of what we consider logically possible.
So why would anyone choose to work with inclusive logic?
The main appeal is its generality.
Okay.
It doesn't assume anything about existence.
Right. Not even a non-empty domain.
It's completely neutral on that question.
So it's like the most fundamental logic you could have.
In a way, yes.
It's not tied to any particular ontology.
Exactly.
That's pretty powerful,
It is.
even if it means accepting some strange results.
It does require some adjustments
Yeah.
to our usual way of thinking about logic.
So it's like a trade-off
It is.
between power and familiarity.
You could see it that way.
Okay, so we've talked about free logic and inclusive logic.
Yes.
But how do we actually assign meaning and truth
Right.
to these statements that might contain empty terms?
That's where semantics comes in. And there are different approaches within free logic itself.
So even within free logic, there's debate
There is
about how to handle these things.
a rich area of discussion.
What are the main approaches?
The three main ones are negative semantics,
Okay.
positive semantics, and neutral semantics.
3 different ways of looking at the same problem.
Exactly.
Okay, let's start with negative semantics.
All
What's
right.
the idea there?
Negative semantics takes a very strict view.
Okay.
It says that any atomic statement
Mm-hmm.
that contains an empty term is just plain false.
So if something doesn't exist,
Yeah,
you can't say anything true about it.
exactly.
Even something like
the golden mountain is golden
right.
would be false.
Because there's no golden mountain.
Precisely.
Okay, that's pretty strict.
It is.
What about identity statements?
Those two.
So, like, the Golden Mountain is the Golden Mountain.
That would also be false.
Because it doesn't exist. Okay, so negative semantics is all about keeping things really clean.
It is.
No truth without existence.
You could see it that way.
What about positive semantics?
Positive semantics goes in a different direction.
Okay.
It allows some atomic statements with empty terms to be true.
So you're saying we can say true things
Yes.
about things that don't exist?
In a sense, yes.
How does that work?
Well, it often involves using two domains.
Two domains.
Yes, an inner domain
Okay.
and an outer domain.
Okay, what's the difference?
The inner domain is the domain of existing things.
Okay, the real stuff?
Yes.
What about the outer domain?
The outer domain includes both existing things
Okay.
and non-existent things.
So it's like a bigger domain.
Yeah.
That encompasses everything.
Yes, even the things that aren't really there.
So how do statements work in this system?
Well, singular terms always refer to something in the outer domain,
Okay.
and predicates have expansions in the outer domain,
Meaning
they apply to things in the outer domain. So a statement like, Sherlock Holmes lived in Baker Street.
okay, a fictional character.
Yeah.
So how can that be true?
Because Sherlock Holmes refers to a non-existent object,
Okay.
but it's in the outer domain.
Right.
And within that fictional world,
Mm-hmm.
he has the property of having lived in Baker Street.
So it's true in that fictional context.
Exactly.
Okay, I'm starting to see how this works.
And identity statements like to are generally true in positive semantics.
Regardless of whether it exists.
Exactly.
Because even a non-existent thing is identical to itself.
Precisely.
So positive semantics is more open
It is.
to the possibility of truth.
It allows for a richer ontology.
Even if it includes things that don't really exist?
Yes.
What about neutral semantics?
Neutral semantics takes a different approach.
Okay, I'm curious.
It says that atomic statements with empty terms
Yeah.
that are not existence, claims themselves,
Okay.
are neither true nor false.
They're just kind of floating there.
They have a truth-value gap.
A truth-value gap.
Yes.
So they're not true, they're not false.
Exactly.
They're just
undetermined.
undetermined. So like, the current king of France is bald.
That would be neither true nor false?
Because there is no king of France.
Precisely.
So neutral semantics avoids making any claims
It does.
about the properties of non-existent things.
It remains neutral on those questions.
Okay, but doesn't that create problems for logic itself?
It does introduce some complications.
Like what?
Well, the law of non-contradiction.
Which says that something can't be both true and false.
Exactly. That
Yeah.
law might become truth valueless itself.
If the statement involved is truth valueless,
Precisely.
so the very foundation of logic starts to get shaky.
It does challenge some basic principles.
How do you deal with that?
Some philosophers use something called supervaluations.
Supervaluations?
Yes.
What are those?
It's a way of augmenting neutral semantics
Okay.
to try to preserve some of those classical logical truths.
So how do they work?
The basic idea is that a statement is considered true
Yeah.
if it's true in all ways of completing the model,
Completing the model.
by assigning reference to the empty terms.
So you're basically trying to fill in the gaps.
In a way, yes.
And if it's true in all those completions,
then it's considered true overall.
and false if it's false in
Uh-huh.
all completions.
Exactly.
So it's like you're looking at all the possibilities,
You're considering all the ways the world could be.
even if those worlds include non-existent things.
Yes.
And that helps you determine the truth of the statement.
It's a way of making sense of truth in the face of non-existence.
So supervaluations are a tool
They are.
to try to keep things consistent.
To bridge the gap between neutral semantics
Yeah.
and classical logic.
But they're not without their own problems, right?
They do face some criticisms.
Like what?
Well, some philosophers argue that they rely too heavily on counterfactuals.
On what could be,
Exactly.
rather than what actually is. And there are also concerns about how they handle logical consequence.
It's a complex and debated area.
So even within free logic,
Yeah.
there are these different philosophical camps with different views on how to handle existence and truth.
It's a reflection of the deep philosophical questions that free logic raises.
Now, beyond these semantic debates,
Yes.
you mentioned that there are some inherent difficulties
There are.
that arise in many forms of free logic.
These are kind of like generic anomalies.
Generic anomalies?
Yeah, things that pop up,
Okay.
regardless of the specific semantics you're using.
So what kind of logical headaches are we talking about here?
One issue is with primitive predicates.
Okay.
In standard logic
Yeah.
and positive free logic,
Yeah.
if you have a valid formula
Uh-huh.
and you substitute a prigative term.
Like a basic term?
Yes.
Okay.
With a more complex one of the same type,
Mm-hmm.
the formula should still be valid.
That's how it works in those logic.
Exactly.
Okay.
But in negative and neutral free logic,
This can fail.
so the substitution doesn't always preserve validity.
Precisely.
Can you give me an example?
Sure. So let's say you have the formula PT, ET,
Okay.
and P is a basic predicate. That formula might be valid.
Okay.
But if you replace P with something like PX,
So you're making it more complex.
yes,
Okay.
the resulting formula PT
Yeah.
might be false.
It's empty.
Exactly.
So the substitution messed things up.
It did.
And that's a problem.
It raises questions
About what?
about whether our choice of primitive predicates
Yeah.
is affecting the truth of our statements.
It's like the logic is sensitive
It is.
to how we choose to represent things.
It's a subtle but important point.
Okay, what other anomalies are there?
Another one is the failure of substitutivity.
Substitutivity.
Yes.
What's that?
It's the idea that you can substitute two expressions that are equivalent
Okay.
without changing the truth value of the statement.
Yeah.
Right. Like if two things refer to the same thing,
Yes.
you should be able to swap them out.
Exactly.
And that doesn't always work in free logic.
It doesn't always work.
Why not?
It has to do with coextensive open formulas,
Coextensive.
meaning they're true for exactly the same existing things.
Okay.
So even though they're true for the same things,
Yeah.
substituting them in a context that involves an empty term
Okay.
can lead to different truth values.
Can you give me an example?
Sure, take the formulas x, 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 ex, and ex of x.
Okay.
Those are all true for the same existing x.
Right.
But if you substitute them into the context where 6 empty,
Yes.
you might get different truth values.
Depending on the specific free logic you're using.
So even though the formulas are equivalent in a sense,
Yeah.
they don't always behave the same way.
Exactly.
That's pretty counterintuitive.
It is.
Okay, any other anomalies I should be aware of?
One more that's particularly relevant for philosophers.
Okay, hit me. Standard free logic has trouble
With what?
expressing sufficient conditions for existence.
What do you mean?
Meaning, statements of the form x say ex.
So if something has property A, then it exists.
Exactly.
Yeah.
But because the quantifier and the existence predicate
Yeah.
range over the same domain,
Uh-huh.
these statements become trivially true.
Trivially true.
Meaning they're true just because of the way the logic is set up.
Not because they actually say anything meaningful.
Exactly.
Okay, so that's a limitation.
It is.
Especially for philosophers who are trying to talk about existence.
It makes it difficult to